let's take a look at how to model with systems of equations. Okay, so now we're going to have cute stories and word problems. When we're modeling a real-world situation, sometimes we need more than one equation to represent the problem. Hence, it's called a system. First, you have to identify your variables. Okay, you need to have the same number of equations as variables. So what that means is if you have two variables, you need two equations. Write the appropriate number of equations. You're usually going to need two. Okay, and then we're going to solve the system using either substitution or elimination. Okay, so we're usually going to have two variables. Okay, oftentimes it's going to be equation number one is usually about money, and then number two is usually like how many. Okay, so if it's money, it's going to be dollars and cents, and then there's usually like how many. Okay, let's take a look at this one here. The school that Jacob is selling tickets for, he goes to, they're having a fall musical, and the first day of ticket sales, the school sold 4 senior citizen tickets and 12 child tickets. Okay, so I'm going to underline this here. It sounds like there's senior citizen tickets and there's child tickets. Okay, so the first thing I'm going to do is I'm going to label my variables. Sometimes people like to use S for a senior citizen, and they could use C for child. Okay, so our variables are going to be S and C. Okay, and now we have to write a system. So I'm going to write the little bracy. Okay, and it says we sold 4 senior citizen tickets. So that's going to be 4 S's. And they sold 12 child tickets. So plus 12 of the child tickets, and then how much was that? $140. Okay, so that's information about how many tickets, and that's how much money they cost. But now there has to be more information because when you have two variables, you need two equations. Okay, let's keep going. The school took in $100 on the second day. Okay, so how did they make $100? They sold 8 senior citizens, so that's 8 S's, and they sold 6 child plus 6 child. Oops, that's a 6. Okay, now we have our system. We have 2 variables, 2 equations, and we have a variety of methods of solving this. I'm not going to graph it, and it seems like it's really set up for elimination. So if I wanted to have the S's eliminate, this first equation would need to get multiplied by -2. Okay, and so the new system is going to be, distribute here, -8S minus 24C equals -240. Okay, the second equation I'm going to write just as is. 8S plus 6C equals 100. Are we ready for elimination? Yes, something is definitely eliminating. If I subtract here, this is going to be -18C. -240 plus a +100 is going to be -140. And then we're going to have to divide a negative by a negative, and that's going to be positive. Oops, this is -280 right here. So that's 180 divided by a negative. And C, the child tickets are going to cost $10. Okay, the child tickets cost $10. We still have to go find S, how much the senior citizen tickets cost. I'm going to put 10 maybe right here. 8S plus 6 times 10 equals 100. 8S plus 60 equals 100. If we subtract 60 from both sides, 8S is 40. And if you divide by 8, wow, the senior citizen ticket is only going to be $5. So it's $5 for a senior citizen and $10 for a child. Okay, let's go on to the next one. Jack and Betty have 28 coins. Okay, and they are nickels and dimes. All right, so let's see. The variables that we're going to use here. The variables that we're going to use for nickels and dimes, I'm going to use an N and a D. I think that makes sense. Okay, and they have 28 coins. Okay, so my first equation, okay, especially with money, is going to be how many. How many coins do we have? Okay, so I've got some nickels. I've got so many nickels, and I've got so many dimes, and altogether that's 28. Okay, now whenever you do the money equations, the next one is always going to be the worth or the value. Okay, how much is a nickel worth? We have to be very careful here. A nickel is 5 cents, so we're going to say 0.05 for a nickel. Plus, how much is a dime worth? Every dime is worth 10 cents. That's 0.10 or 0.1 D. And the value of the coins is $1.95. $1.95. Okay, so now we have a system of N's and D's, and we can solve it. Maybe what I'll do is multiply. I'm going to multiply this entire equation here by, I'm going to multiply it by 100. Okay, why would I do something like that? When I multiply by 100, the decimal gets moved over 2 times. Okay, you can use your calculator for this. But what I'm doing is I'm saying 5 cents for every nickel. And if I multiply this by 100, that's going to be 10 cents for every dime. And if I multiply this by 100, that's 195 cents. And the numbers are just a little easier. You don't have to do this. You can multiply here by a decimal, or we could always do substitution. Okay. Now to get something to eliminate, I think I'm going to multiply by a -5 to get the n to eliminate. -5n minus 5d, and 28 times a -5 is going to be -140. Okay, so now we can go ahead and eliminate. 10 minus 5 is 5d, and 195 subtract -140 leaves us with 55. This better come out nice, because how many dimes do I have? I don't have half of a dime. I have 11 dimes. I have 11 dimes. All right, that's only half the answer. So we need to go back and plug in 11. I'm going to plug into this top equation. That one looks a lot easier. N plus 11 equals 28. And how many nickels do we have? 17. So again, we don't have any half nickels. Okay. If you don't like the decimals or multiplying by 100, we could always do substitution. Okay. What we could have done was maybe moved the d over. We could have said n equals 28 minus d, and we could have substituted this in right there and then did a substitution problem with decimals if you like. Okay, whatever method you're better at, I say go ahead and use. All right, let's do a couple more examples, okay? The more that we do, the more you see, the better it's going to be. Six Flags is a popular field trip destination. And this year, the senior class at East and West both planned trips there. The senior class rented and filled 14 vans and one bus. Okay, 14 vans and one bus. Maine West filled 7 vans and 14 buses. Okay, every van had the same number of students as it did in the buses. All right, so it seems like the story is about two things. You have to figure out the two things so we could label our two variables. I see vans and buses, so I'm going to use V and B. Okay, let's make two equations. So our system is going to have one for East and one for West. Okay, they filled 14 vans, that's 14 V's, plus one bus, that's one B, and there's 166 students. Okay, now how about Maine West? They filled 7 vans and 14 buses, and they have, wow, 434 students. These numbers just came out nice. Okay, find the number of students in a van and in a bus. Okay, so I think I'm going to do elimination again. That's just my favorite. We could eliminate the V's or the B's. Here I would have to multiply by a 14, and that might get really large. So I think I'm going to choose to eliminate the V's by multiplying by -2. Okay, so I'm going to write the new system. The top equation, nothing changes. The bottom equation, everybody gets a -2. 434 times a -2 is going to be -868. Okay, and now we're eliminating. -28 plus 1 is -27b. -866 and a positive 166 leaves us with -702, and I hope that divides nicely by a -27. And what do we get? A positive 26. Okay, so how many students are in a bus? 26 students, okay, in the buses, in each bus. And now I have to figure out how many go in a van. I'm going to put 26 in right there. That seems like the best place. 14V plus 26 equals 166. If you subtract 26 from both sides, that gives us 140, which does divide nicely by 14. So the number of students in a van is 10 students in a van. Does that make sense? Oops, in a van. Students in each van. If you've got an answer like 7,000, there's no way you can squeeze 7,000 students in a van. So of course that's going to make sense. Okay, and the last one I think is the easiest of all the types of problems. There's not a lot of story here. It's just saying that the sum of numbers. Okay, so the story is a little blah. So when you go to pick your variables, you have a lot of choices here. It just says two numbers, the same two numbers. So I'm going to go old school and use the variables that I was used to. I'm going to use x and y, because this is kind of a boring problem. This is the variables that I used to use. Okay, the first one says the sum. Sum means to add. I have to add the two numbers. So add these two numbers, x plus y. The sum is 24. Okay, the difference of the same two numbers. Difference means to subtract. So I'm going to take these two variables, x and y, and I'm going to subtract them. And the difference is 4. Find the two numbers. Okay, this is kind of boring. It's set up for elimination. I'm just going to go ahead and start. Y's cancel. Don't forget to add these here. You combine them. 1x and 1x is 2x. Add these together here, you get 28. I think the first number is 14. If I go ahead and plug that in, I'll use the top equation. 14 plus y is 24. If you subtract 14, y equals 10. Is this true? Let's just go ahead and check. Okay. The sum of the numbers is 24. Do these numbers add up to 24? Good. Is the difference of these numbers 4? Yes. Okay. Whenever you have a word problem, you can take your numbers and see if they make sense. Okay, we are going to practice this some more, so hopefully you paid real good attention.